It's so cool to be here in India and JEEConf. I've enjoyed it definitely so far. The topic of this session is, as I said, Spring 4, Java EE 7, or both. So before I start, I'll just introduce myself. Even though I represent Sweden in this case, I'm actually from Norway. But I live and work in Sweden in a company called Cybertron, where I act as a software architect. I've been in the consulting industry since '98, and I'm working in Norway, Denmark, Sweden, and in Germany as well. I wrote my first Hello World in '95, so I've been around Java since the beginning. And I've worked with it ever since. I've worked with Java EE, I've worked with Spring, and most enterprise side of it. So the content of this presentation will be mainly demo-based. I'll show a lot of code. But I'll first just go a short introduction of Spring and Spring 4. Then I'll go through Java EE 7. And then I'll compare them a little bit before we show a demo of Spring 4, Java EE 7, and the combination of them. And as I said, there will be code. A little history. Java Enterprise Edition has been around since around '98 when Java Professional Edition was launched. And it's been upgraded more or less regularly since. Java EE 1.2 was a big thing for some at the moment. And, but it never really actually gained anything because it was so hard. You had to implement so many interfaces, so many configuration descriptions, and it never actually gained any momentum. So when Rod Johnson announced Spring in 2002, we just jumped at it. Finally something a little bit more lightweight, something easier. And Spring 1 came in 2004, and since then the two kind of platforms or frameworks have followed each other. And I have to say that I'm a Java EE guy, and I like the Java EE framework, but Spring has always been a little bit ahead. It's always been better, and getting new things earlier. Until June last year, when Java EE 7 was launched, it took a step ahead of Spring. And that lasted until January this year when Spring 4 was announced, and now they're pretty much parallel again. The current version of Spring is 4.05, but I think they're working on 4.1. Let's jump to Spring Framework 4. I'll give a short introduction of it, and then it's by no means a complete walkthrough. I'll just show a few concepts so we can have something to compare with later. How many are using Spring 4? We got the older versions of Spring. Okay, you got up there. It's much better. Spring Framework are composed of these components. I won't go through them in detail, but we'll show later on how they compare to the Java EE counterparts. And as you have been working with Spring, it's a lot of XML, right? We've been coding in XML forever, and it's a nightmare. But I guess most of you are aware that it's not that anymore. And it hasn't been for a while. So you can actually write pretty good Spring application without a single line of XML. And that's kind of a relief. I mean, we are Java programmers after all, and not XML writers. So, which you prefer? I mean, you can mix and match. It's more or less up to you. So what's new in version 4 then? When it was released in 2004, it has had significant major revisions. The 2.0 release provided XML namespaces and aspect J. Spring 2.5, we got annotation-driven support and configuration. And Spring 3 introduced Java 5 foundation. So one of the new things when they launched Spring 4 was this new Spring.io stuff. You don't have to search around and look at the other different companies contributing to Spring anymore. It's one place, it's pretty well documented, it's easy to find, and everything is there. Spring 4 supports Java 8. And I'll show you a couple of examples. They've implemented the repeatable, so rather than having to do it the old-fashioned way of wrapping it in curly braces, you can now just repeat the animations. And it makes the code clearer, easier to read, less to write, less to hit wrong. Those of you who are familiar with Spring know that there are a lot of callback interfaces. Here's the example of the row mapper that is used by the JEEConf template. And I think it's more or less by accident, but this fits right into Lambda expressions and method references in Java 8. So it's kind of a pure luck, but a side effect of their really good, consistent design. This wraps right into Lambdas. Spring 4 and Java EE support. That said, it's Java EE that is the baseline. They support Sorted 3.0 and JPA 2.0. They also support some of the Java EE support specifications, such as JMS 2.0, JDA 1.2, and JPA 2.1. And beam validation and concurrency of builders. But it actually doesn't support the complete Java EE platform. And I'll show examples of that later. They've introduced Groovy as a definition language. I don't know why they did that, but it's cool for guys who like Groovy. In my opinion, it's just another way of writing something you can do easily. So somebody likes it, and it's there. They've done some core container improvements, like generic olivars. So now you can, depending on the type, get injected what you want here. That's pretty cool. They've done some improvement in the web modules. Like if you've been implementing REST interfaces in Spring, you probably know that you have to use the app controller and app response body to get, for example, JSON synchronized. Okay. But now they have combined this in a REST controller, so you don't have to write both these annotations. It's more convenient, but it's pretty nice. But it's still not the same as JAX-RS, and I'll show that later. They have excellent support for WebSockets and messaging, and the Spring WebSocket supports both the JSR 356 WebSocket in Java 7, but also Sock.js as a fallback. For example, if you're using later browsers than iOS 10. And they also have Spring Messaging, which supports stomp messaging to WebSocket clients. So that concludes the part on Spring 4. Let's have a look at Java EE 7. So Java EE 7 has consists of these components. The ones in blue are the ones that were new for Java EE 7. The other ones are updated. Note that the JMS got a long needed upgrade. It's been one of those forever, and finally it's got upgraded. Lovely. So the focus of Java EE 7 was developer productivity, HTML5, and meeting the end customers. And we'll have a look at each of those separately. So for developer productivity, they removed a lot of the configuration and boilerplate code that you need to do to implement your stuff, and you can focus on the core functionality of your applications. So they're stripped it down to a minimum, and they have aligned the APIs to each other, so it's very similar how you code, not depending on which technology you're using. And CDI has been up there and is the core component model of Java EE. An example of how simple it's been is that this is an enterprise Java kit. And if you've been coding EJBs in the late 90s, you know that it wasn't this simple. You had to implement at least 3 interfaces and a lot of XML configuration files and deploy it in a separate jar file. Now it's just this in 13 code base. So EJBs are actually only. They've modernized the platform and added support for HTML5. One of the things are support for WebSockets, and this is how easy it is to create a WebSocket endpoint. And it's pretty much similar on the client if you want to use a Java client for WebSockets. For meeting the enterprise demands, there are 2 significant changes. One of them is that they added support for batch applications. So you can now actually run your batch applications in your Java EE container. And that's pretty cool, actually. And they modernized the JMS API. And if you've been writing JMS applications earlier, you know that it wasn't this easy to configure a JMS client, for example. So who supports Java EE 7? Of course, we have Glassfish, which is the reference implementation. We have Wildfly, which is the open source version of JBoss. And we also have a Korean application server that supports it. But I think that the Glassfish and Wildfly are the 2 major ones that we are actually most exposed to. So that was a brief introduction to Spring 4 and Java EE 7, and now we'll have a look at a little bit of differences and compare them together so we can see how we can mix them better. So if we look at the Java EE 7 components and see what is actually directly out of the box supported by Spring 4, it's the ones I've drawn in purple here. The other parts are either specifically implemented for Spring or is supporting older versions. But you can mix and match, as we'll see later. So that Spring 4 supports Java EE 7 is kind of an overstatement, but it does anyway. Java EE 6 is the baseline. So if you look at what's supported in Spring 4 by Java EE 7, the other way around, you see that there are also a lot of stuff that isn't supported by Java EE 7, which is supported by Spring. And the major difference between a Spring application and a Java EE application is that with Spring, you run it in a Spring container, which you package with your application. So the container is a part of the WAR file. Whereas in Java EE 7, the WAR file uses the container, which is a part of the Java EE 7 application server. So the application server provides the implementations of the specifications, which you reference in your WAR file. So here comes the thing, if you want to combine the 2 approaches, you have to include the parts of the Spring container that you're actually using, and you need to deploy it in a Java EE 7 container. And you need to find out how to get your beans or classes, components to cooperate between the containers. And that brings us to the demo. What I'll do in the demo is I won't create it from scratch. I show you a Spring 4 application, show the exact same application in Java EE 7, And I'll combine the two approaches and create the exact same application using both technologies. I'll run them in different application servers, and we'll see what configuration changes need to be done. For example, Wi-Fi, Glassfish, and JEEConf. And if time allows, I'll also show you how to create the same application using Spring Boot. Because I know there's a parallel session here, and those of you who are here, you can see the Spring Boot presentation online later, but if time allows, I'll showcase them on Spring Boot. So, this is my Spring 4 application, and as you see, I have added a couple of dependencies to the Spring framework. I have the Spring Context and Spring Web MVC. And also added these servlet APIs since Spring 4 supports Servlet 3.0, and I want to use Spring Servlet 3. If you look at my project, there are no XML files whatsoever, it's just a context file per gearbox. So I don't use any XML configuration for Spring. What I do use is a application initializer which implements the web application initializer. And this is kind of the replacement for the web XML file. What I do here is that I create the dispatcher servlet, which is a part of Spring MVC. And I just register my configuration context. Let's have a look at that one. This is a new feature of Spring 4. This is how I enable Spring MVC. So previously you had to have a WebXML file where you define the dispatcher servlet, and you had to have a dispatcher servlet XML file to configure how you want to use it. This is all you need to do for Spring MVC. If you look at my control class, it's pretty simple. I'm using the REST controller annotation. I'm auto-wiring a counter, so I can use injection to show injection. And I'm using request mapping to say that before I get request to this, I want to create application JSON, and I'll just write out hello. And it's very simple REST application using Spring 4. Let's run it to show that I'm not kidding. I'm running this one in Wildfly. There's my welcome page. If I go to it, counts. So it's going to have the state and just increments. That's a very simple application, and as you see, it's the other classes are just this is just a plain Java class, and the counter is just increments. So it's very. So that is how we can create a simple REST application in Spring 4 using only Java configuration. So if we look at the same application in Java EE, what I have here is one dependency and it's provided. So this war will be significantly smaller. So if the size of the war file matters to you, then Java EE war files will be smaller than the Spring because you don't include the container in the war. This is the only dependency, and another benefit of having fewer dependencies is that there are fewer sources of errors. If you look at this one, there are no configuration files here either. My value objects are exactly the same. I have a application config file, which is the configuration for JEECRS. So the application is a JEECRS. So just extend and say that I want /API to be the context of my JEECRS resources. If we look at the controller, it says that it's listening to the greeting. I'm injecting using CDI, the counter, and I have a get method, and I produce application JSON. So here's the difference between Spring, where you have the request mapping, and you have the request method and the response as attributes to that one. Here there are annotations. And I just return the greeting. Let's run this one. And it's acting actually the same. The code base is pretty similar, the configuration is pretty similar. It's not that much that differs between them. So what if I want to combine these two approaches? I see here that then I need to include the Spring dependencies that I want to use. And I also have the provided Java EE7. If you look at the code, there are no XML files here either. I have the application initializer. It's pretty similar to the Spring one, only that I don't define the special server because I'm not using Spring MS either. So I just register the application configuration. And the application configuration is pretty similar to the one I used for Java EE7. Only I've also added some Spring annotations there. That means I'm now able to call into the JEECRS implementation from the Spring context. There's one more thing I need to do is that in my controller, see here that I'm annotating it as components, so it will be known by the Spring. And I'm using auto wiring instead of ingestions. But I'm using the JEECRS stuff for the request method. And I also need to register this class for auto wiring to be able to use the Spring injection. So there is a little bit more configuration code to do to get this work. You see that this one behaves exactly the same. So now I run it just in a Java EE container. And what if I want to run it, for example, in another container, or say that a non-compliant Java EE container? What do I have to do then? Just prepare my code a little bit. Let's have a look at the Spring config again. So if I want to run this one in a Tomcat rather than in the Wildfly, or even if I want to run it in another Java EE7 container such as Glassfish, because it doesn't necessarily have the same JSON or whatever I'm using as implementation specific stuff in my application server. And Wildfly is using Jackson for the JSON serialization, and for Tomcat we need to provide it. If you look at the code, I don't have to do any changes at all, because this is a Spring application, so it's just a matter of a dependency that aren't available for me in the Tomcat container that I have to add. So if I changed the runtime here to use Tomcat, I'm not running this one in a Tomcat server. I stopped the Wi-Fi and and it behaves the same way as it did in Wi-Fi, and it's just to add a dependency that wasn't available for me in Tomcat, or whatever application server I want to run in it. I can also run this one in Glassfish if I want to show that later. But look at the Java EE counterpart. I don't need to do any changes in the .xml file, because this is dependent on the container, and it's just dependent on the specifications of the container. But what I need to do to, for example, run this one in Glassfish is that since Glassfish is using Jersey for REST implementation and Wildfly is using REST Easy, they have a little bit of different requirements for what you do. And what I've done here is to tell Jersey that I want to use Jackson or JSON. And I'll also add the controller. This one isn't actually needed, and it's actually a good thing to do it, even though you don't need to do it, because then it's so much easier to version your API, for example. Just add another configuration class to point at the same version to. And you can have another implementation class serving the same resource. So if you run this in, for example, Glassfish. And it's answering from Glassfish. So I only need to change a few things that are depending on the implementation of the Java EE 7 specification. So the lesson from this is that even though you're using Java EE 7, which is a standard and is a specification, the implementing container may be different. And you need to take that into consideration when you're using it. So if you look at the combination, there is a little bit more to do if I want to run it in a non-Java EE compliant container. Because when I run it in Wildfire, I could use the provided annotation for the Java EE web API. If I want to run it in, say, Tomcat, I need to add a few dependencies. And that is, I'm using the CDI, so I need to have injection. I need to add 3.1 as a provider because it is provided by Tomcat 8. If you're running in Tomcat 7, you don't need it. And I also need to have the REST easy Spring to have the JXRS or features ready for me. And I need the same Jackson provider, which is available in Wildfire. And in my code, I need to do some more changes. What I need to do here is to tell the container that I want REST easy to map for my REST resources. And I also need to register the REST easy server. And I need to make my application Spring aware. So I need to register the Spring processor server aware. So there is a bit of configuration to be done if you want to combine the approaches. My application configuration class is exactly the same, so I don't need to do anything there, and the rest of my code base is exactly the same. So now I'm running a Spring 4 combined with Java EE 7 application in Tomcat, which is not a Java EE 7 compliant container. That's one of the benefits of Spring, that you can actually combine them together pretty easily. And this one runs just as fine in for example, Glassfish. Well, rather, I promised to see an example using Spring Boot. Have anybody checked out Spring Boot? Yeah. This is pretty cool, actually.
I have a question related to previous example.
Yes.
So, can you explain the reasons? What was your initial intent to combine with those? Because if the only benefit right now is just using Jersey as a JXRS implementation, the Jersey is easily combined with Spring.
Yes.
Just via Jersey Spring integration, and if your web layer should be JXRS compliant, it easily can be done without this. So I suppose there are some other reasons for this artificial combination. So can you please share your own experience and advise when this might be useful in a real production?
Yeah. The question is, in this demo, I'm using JXRS and Jersey as an example, and the question is why? And the answer to that is it's convenient for demo purposes. But as you say, it's not the actual case you would use in production. Another more a better example is, for example, if you have a Java EE application and want to use Spring Batch combined. That's a case where you actually can benefit from it. Or you have another Spring isolated features that you want to have in your Java EE application. So there are things that Spring supports better than Java EE. Or if you have an existing code base of a Spring application, but you want to modernize and want to get it on a Java EE 7 architecture, and then they can do it gradually by combining. So the fourth way of doing this is to use something called Spring Boot. And here, the only dependency I have here is Spring Boot startup. And my code is exactly the same. Only my application configuration class has enable auto configuration, and it has a main method which runs the Spring application. And I'm just using the default from Spring Boot. If I stop my Tomcat here. We'll run this one. We'll actually start up a Tomcat on port 8080. So this one actually has a Tomcat integrated in the workflow. So this is here I actually package Tomcat within the war. So I have Spring and Tomcat and everything in the war file. The war file gets bigger, but in some cases where you want to embed your runtime in your application, this is a good way of doing it. And you can also, they have lots of stuff for configuring it in the right way. So have a look at Spring Boot, it's pretty cool. So, that concludes the demo part of this application. And let's sum up with, what we did here. The Spring 4 configuration, this is equivalent of the WebXML configuration. And the enabled WebMZ is the special servant and the special XML file which we usually use for Spring and WebMZ. The Java EE configuration is doesn't need anything more than the application path for the JEEConf application in this case. And if you want to combine them, mix and match the annotations, you need to do some code changes to get it to work. And here I mix the annotations from Spring and the application configuration for JEEConf. The portability, Spring 4 doesn't need any configuration changes at all. It doesn't need any code changes. You just need to add the extra dependencies to one file that your application requires. Java EE 7. You need to do some minor configuration changes depending on which of the specifications or implementation you are relying on in your application. You don't have to do any code changes and any dependencies in the form because everything is provided by the container. You have to be aware that what the implementations that the container provides may differ. So if you rely on that, you need to do some configuration changes. if you mix them, you need probably to configure your applications again. You don't need to do any code changes; it will work just fine. And you need to add the dependencies that you rely on. So to conclude, Spring 4 is actually more affordable, even across Java EE 7 containers. Java EE 7 requires less configuration. The WAR file is significantly smaller. I think the WAR file of the application I made here today is like 8K. And the Spring counterparts is 10 megabytes. So it is different in WAR file size. So if that matters, and the size of the WAR file has impact on deployment time. But you rely on the container. Java EE 7 requires less dependencies because they are provided for you by the container. And mix them is possible if you need to do it, but it requires a little effort depending on what you actually want to do. One tip of advice is favor one framework over the other. Listen to the developers. And don't start with the intention of mixing, but do what you know, do what your developers want to work with. Are they experts at Spring? Well, stick to Spring. Are they experts on Java EE? Stick to Java EE. If you need a migration path from Spring to Java EE or the other way, it's possible, and you can combine them as you go. But it requires a little bit of effort. If you want to look at the sources from this demo, you can find it on GitHub and play around with it, use it, do whatever you want to do it. If you want to comment on it or anything, just Google or tweet me or anything. So that's what I had for today, and I thank you for listening and hope you enjoyed it. And I think we have a couple of minutes for questions. Yes?
Well, I'd like to ask you, please highlight a bit how precisely you bringing up Spring context from Java EE context without registering server dispatcher or application context list or whatever. What annotation are you using? When you start the Java EE context, how is it bringing up Spring context?
Okay, so the question is how to make the Spring context available for the Java EE part of the application.
Start, yes.
Yes. In this case, I used the REST Spring to get it run. You can start it in the server context, and depending on which way you want to do the injections, you may need to do some code changes to make it injectable. So if you want to inject Spring applications in your Java EE applications, you may need to create a provider for it, a CDI provider. Then you can use inject to inject it. And then Spring context, you need to start
Can you
in
show
the
one
usual.
example? The place where you start the Spring context from your REST context.
Is this one?
Oh, I see. So you just register it manually, you can do it with annotations.
Yeah, or you can do it in WebEx.
And what if I want to use just pure Spring? I still need somehow to make Spring context start.
Okay, Spring context starts by implementing this class. It will scan the application for you, and it's just there.
Is it a Java EE interface?
No, it's a Spring interface.
Then my question first is, Java EE won't be scanning Spring, or is it just that?
Sorry?
Java EE won't be scanning for any Spring
No, it
related
won't.
stuff. So who is scanning? When you use WebXML, you just register dispatcher servlet, and dispatcher servlet does the rest of the tricks. How you make these presentations? That's my question. Let's say you have pure Spring, you don't have any Java EE file. How you make the web container to scan for Spring configuration files to return to?
Okay, I see. This is the pure Spring application,
Yes.
and it implements the web application initializer.
I see.
And in the web application initializer, I registered the application configuration.
Oh, yeah.
And the application configuration does component scan
Yes. Now,
and scans for components.
thank you. I just wanted to see this when you register application configuration. After that, just
Okay.
thank you.
Yes.
I would like to ask about the performance. Have you measured performance based on Spring application and Java EE, pure Java EE application? Like, what's the performance?
The question is, are there any performance differences between Spring and Java EE? And I think it's more dependent on your application than the framework. I can't say that I've seen any performance impacts that are directly from using Spring or Java EE. The deployment time will often be faster in Java EE 7 application because you have everything ready there and you don't have to scan the context that's like Spring and start everything.
Spring is kind of like a second container, right?
Yes, but when in runtime you run the application, I haven't experienced any performance issues related to the framework. It may be in your code, so I'll start there.
I mean, like, is there any like extra overhead influenced by Spring, like in comparison with just like pure Java EE? Because if we run in pure Java EE container, like Glassfish, right? And there is simply no need to extra container like Spring. And
so the question is does the Spring container introduce any performance overhead? And I think I can say no, it doesn't.
Thank you.
Okay, thank you.